bottom. And we're going to streamline this a little bit. It asks us to graph all of these things, and we're just going to learn the technique of how we can go from our original parent graph to the final graph right away. So your original parent graph is this one in the red box. That's your absolute value graph. That's on our colored paper. We know what it looks like, and we want to graph all of this. So now we're going to look at what's outside, what's inside. We're going to start by just labeling all of these things. So here's my main absolute values, so I can really see these are the numbers that are inside. This 1/4 is outside. V for vertical, C for compression. That would be a vertical compression. You would multiply your Y values by 1/4. Then we have two horizontal things happening. This is going to be a horizontal compression. Remember, x's are liars. We're going to multiply our x values by 1/2. And this is a horizontal translation. We're going to go 3 to the left. Again, the x's are liars, so that would make it go 3 to the left. And then the 4 at the end is a vertical translation, 4 up. So first of all, we can look at the equation and we can describe it. And then we are going to see what this final graph looks like. So in order to see what the final graph looks like, we have to, in our head, have the original graph, which I'll draw in red here. Here's our absolute value graph. Very important point would be 0, 0, because that's where it sort of changes directions. Now, we have a bunch of things to do. We have to multiply the y by 1/4. We have to multiply the x by 1/2. We have to move 3 to the left and 4 up. So I have a bunch of points I can label on here. I'm going to choose one on one side and one on the other. And when choosing those points, a little bit of strategy involved. I'm going to choose 4, 4. Because you see that we have to multiply our y value by 1/4. So at least I won't have to do, if I use 1, 1, I'm going to have to use fractions. If I use 4, 4, then I don't have to use fractions. Same thing, I'll choose a point on this side. Maybe I'll use -8, 8. And this is how we're going to show our work to do this all at once. We're going to take those 3 points that I did in red. I had 0, 0. It doesn't matter the order we write them in. 4, 4. And -8, 8. And we've done this before, but this time, when we have so many, we are always going to do all of our stretches / compressions and reflections first. And we're going to do all of our translations second. This will allow us to make less mental math errors. And then above each of these, I'm going to write what's happening. So what's happening for stretches and compressions? I need to multiply my x by 1/2 and my y by 1/4. What about my translations? I'm going 3 to the left and 4 up. And the mental math is actually quite easy, but it's also quite easy to stop paying attention and make a little mistake. Okay? So if I have to multiply x by half, well, 0 will be 0. 4 times by half is 2. Negative 8 times by half is going to be negative 4. Multiplying y by a quarter, well, 0 will still be 0. 4 will be 1. 8 multiplied by a quarter is 2. So I do that preliminary work first. And then I need to go 3 left and 4 up. So if I go 3 to the left, 0 will be negative 3, negative 1, and negative 7. And moving 4 up, I'll have 4, 5, and 6. So based on those points, I'm going to, on my grid here, I'm going to draw my axes like that because I know I've got a bunch of negative points. And I need to label negative 3, comma 4. So I go 1, 2, 3, 1, 2, 3, 4. There's negative 3, comma 4. Negative 1, comma 5. And negative 7. Negative 7, comma 6. Draw the shape of the graph, an absolute value graph going through those points. And now we were able to graph this very big, complicated equation relatively easily, just using the fact that we know what the original graph looked like and we know what the changes are. So this will be our strategy moving forward. We have a bunch of things that we have to graph. Think about the points on your original graph. Think about what's happening, and to make your math easier, we'll do all of our stretches and compressions, reflections first, followed by our translations second. And if we do that, no problem, things are going to work out nicely. Okay, let's go to example 1. Here's the graph of g of x. Sketch and label its image after a vertical compression by a factor of 1/3, then a translation of 2 units up. So if we label these 4 points, I'll do them right here. I have negative 5, comma 3, negative 2, comma negative 3, 1, comma 0, and 4, comma 6. We have a compression and a translation. So I'll do them separately. I have a vertical compression by a factor of 1/3. So above this, I can show that by saying my y values have to get multiplied by 1/3. And then I need to go 2 up. So only my y values are getting changed. So one of the things I can do relatively quickly here is I know my x values aren't getting changed, so I can just rewrite them. And now my y values are multiplied by 1/3. 1, negative 1, this will be 0 still, and this will be 2. One thing that I recommend, the mental math is easy, which makes it really easy to stop paying attention for a second and making a tiny mistake. What you didn't see when I did that is after I did each one, I double checked it. So easy math, it doesn't take long to double check it, but just to make sure that all my values are right. Because one little mental math mistake and then your whole graph all of a sudden looks bad. And you're like, what happened? Okay, now 2 up, again that affects the y, so I can just rewrite all my x values. Go up 2 is 3, up 2 be plus 1, up 2 is 2, up 2 is 4. And I can label these points. -5, 3. Oh, interesting. That ended in the same spot. -2, 1 is there. 1, 2, and 4, 4. Connect those lines. And we have our final graph. Now, normally I just do the question, construct the understanding question for you and give you your questions for practice, although something important happens in the regular question as well. So we're going to look at this one as well, okay? We've got a horizontal compression. Oh, yeah. I know what I wanted to do. I wanted to, before we get to this, one of the things that I want to do for this is write the equation, because it says sketch and label. We've got our points labeled, but let's label it with its actual equation in terms of the function g, just to practice that. So if I have y by 1/3, that 1/3 would be out in front. And up by 2, that also would be outside. So this equation would be 1/3 g of x plus 2, because everything is outside. And for doing the question off to the side, you could do the points exactly the same. I would choose this point, and this point. So, oops, that's not the one. Example 1, here we go. I mean, we could do these 4 points, and you see that you'd have to multiply your x values by 1/2, and your y values would move 3 to the left. We could do the same points and get the equation. But what I wanted to point out with this one is, what would the equation be? If we had one arrow that said x is getting multiplied by 1/2, and the second arrow would say that we're moving 3 to the left, and we wanted to write this equation, you see that all of these things are affecting the x values. So they're all going to be inside. But writing this inside is trickier than writing the outside parts, and I'll show you why. Okay? My question is, which do you think is right? Should I write it this way with, oh, x's are liars, right? So this 1/2 should be a 2. And then this 3 left, x's are liars, should be a +3. Or should I write it this way? X's are liars too. Those are different. One of them has an extra set of brackets, right? Because if I distribute this 2, I would get 2x plus 6. And this one is 2x plus 3. One of them is right, one of them is wrong. Okay? This one, the one you probably want to be right, is wrong. The x's are tricky, right? That one I'd like to be right, but it's wrong. You always will write a special note here at the bottom. When do you guys have to leave?
Right.
Okay, can you wait, like, I've got a few, like 3 or 4 minutes? Yeah? Okay. So let's finish this note, then I'm going to hand everything you need for next week. So you have those papers. You guys got the first quiz?
Yeah.
Okay. All right. So when you have, and this only happens with horizontal, stretch slash compression slash reflection and a horizontal translation. Again, this only happens when you have both of these horizontal things, so that's why I made them in blue. When you have a horizontal stretch, compression, reflection, and a horizontal translation, you have to write it in its factored form. If we go back to the very first question that we did today, I don't know if you noticed, but the 2 was factored out inside the absolute value. So if you were trying to be like, oh, which is the right way, in our very first question, it was factored out. I guarantee this is going to screw most of you up most of the time. I even had a student once who's like, oh, I set a reminder for 8 p.m. every night. Remember factored form. And then every night they'd be like, but then there's going to be so many important things in this class. You could put have reminders on your phone for like an hour every night by the end of the semester of all the important things. But this one, you're going to forget sometimes. It's going to come back and get you. Okay, questions to circle are 4, 5, and 6.